Okay, so before I go over the parent functions, I want to make sure everybody understands what it means to square something and what it means to cube something. Squaring means to multiply by itself. So if I squared -3, what's -3 times -3? Positive 9. -2 squared? -1 squared? 0 squared. 1 squared. 2 squared. 3 squared. So what do you notice? Every time I square a number, it's always going to be a positive. Why? Because a negative times a negative will always be a positive. You're never going to get a negative if you square something. All right? What about cubes, though? Well, cubing means we take the number and we multiply it by itself 3 times. So if I cube -3, is it going to be positive? No, because if I multiply a negative times a negative, well, that's a positive, but then it reverts right back to being a negative when you multiply by another negative. What is that going to give you? So here's the trick. If it starts with a negative, you're going to end with a negative, because it always reverts back to its original sign when it's an odd exponent. Okay, what about -2 cubed? It'd be -8, -1 cubed? 0 cubed? 1 cubed? 2 cubed?
6. 8 cubed is 8.
And 3 cubed? 27. Okay, now what happens? Well, we can write down that little note that we had. We said with squaring, it will always be a what?
Positive.
And cubing keeps original sign, meaning positive or negative. Okay, so if I want to fill in these tables, we're focusing on square roots and cube roots. Well, a square root is an inverse of a what?
But
What's the square root the inverse of?
cube.
Of a square. And a cube root is the inverse of a cube, which we went over that, right? They're inverses of each other. They cancel each other off. So if I'm going backwards, what's going to happen if I square root 9? Square root of 9 is 3. How'd you get that? What question do you ask yourself in your brain?
But I didn't know if it's negative or positive.
Oh, because when you square root a number, you can have either or. But in a calculator, it only tells you the positive. So anyway, square root of a number means what? What do you ask yourself in your head? What times, huh? Itself will equal x. That's your question. When you have a square root of something, you ask yourself what times itself will equal that value, because you're reversing it. You're trying to find what that original base was. Similarly, a cube root, bless you, a million times. I said bless you a million times. All right. Cube root is almost the same thing, except what times itself? 3 times. Equals x. Okay, so back to what Julie kind of pointed out. She was like, wait, but the square root of 9 could also be a negative. Why? Why can the square root of 9 be both negative and positive?
Because they're all equal positive.
They're all going to give you the positive 9. So you could have either or. But in calculators, when we graph it, it always does what's called the principal root, where it's the positive version only. So, yeah. We're going to stick to what the calculator says. But if we were to be graphing inverses, that's why it forms the parabola, kind of. But anyway, let's start filling them in. So if I want to do the square root of 9, square root of 9 is what? 3. Okay, what about 4? The principal root of 4 is 2. What do I mean by principal root? Well, what did I say earlier? I said Julie said we can have negative or positive, but the calculator will take the principal root, which will always be the positive version. So we're going to just ignore the negative side, even though we know that that's part of it. Okay, and then square root of 1? 1. Square root of 0?
Can I go get some tissue?
Yeah. Square root of negative 1? Because 1 times 1 is negative 1? Oh, because negative 1 times negative 1 is negative 1? Remember the question. What times itself will equal this value? So what times itself will equal negative 1? 1 times 1 is 1. That's not times itself then. Why is it error? Because every time you square something, it's always positive. Can you ever take a square root of a negative then? No, there's no such thing. So you're right. It will say error. It goes against what we mean by square root. You can't take the square root of a negative because there's no such thing as a negative square. What about negative 2, or negative 3, or negative 4, or negative 5? Any other negatives?
Errors.
It'll all be errors. All right, so this is the original function. Go ahead and graph it. We got 9, 3. Off the grid a little bit. 4, 2. 1, 1. 0, 0. There you go. So it has a starting point, and then the rest of it will go to infinity. Because none of this section will be graphed since we cannot take the square root of a negative. All right, let's do cube roots really quickly. Okay, what about negative 8? The cubed root of negative 8, does that exist? Can you have a cubed root of a negative? So there's no such thing as negative cubes?
Yeah.
Look up there. We can't have negative cubes?
Yeah.
Yes, we can. So what's the cubed root of negative 8? Negative 2. Right here, look. If you take the cubed root of negative 8, it had to have been negative 2. Why? Because we ask ourselves, what times itself 3 times will give you that value? Well, negative 2 times itself 3 times is negative 8, right? So then what's the cubed root of negative 8? All right, what about negative 1? Cubed root of negative 1 is? What about 0? 0. And 1? And 8? 2. So are we going to have errors with cube root? No, because we can have both, negative and positive. If I graph this, this is like that cube root frisbee that you would see at the beginning of the year. We have negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, 8, 2. You'll see how it kind of dips and it switches directions from the negative side to the positive side. Same distance. Because we just plugged in numbers. Okay, so these are your parents. When we get back, we will go over the transformations of these. That's y'all, by the way.
Oh my god.
You'd be